Zev, I think we can start.
Okay, so hello everyone, and thanks for joining our webinar today. I would like to introduce Israel Gross from Layer 7 Defense that joined me today to discuss an insightful topic for application security. Application security is a wide definition and paramount area of API layer that we'll discuss today. In terms of agenda flow, we will start from reviewing the big picture of API dominance, the critical dependencies, security gaps, and move to our joint solution that enables Agile API security with a finalized slide on a case study example. We'll also provide a giveaway bonus at the end of this webinar, so stay with us and don't really go anywhere. You will be entitled, the ones that will be attending this webinar at the end will be entitled for this giveaway. Q&A will be reserved towards the end, so feel free to place your questions in our Zoom chat. And before we start, welcome Israel, and please introduce yourself briefly before we start.
Yeah, thanks, Zev, for hosting me in this special webinar. I'm very happy to be here today with, I see people from worldwide attend this webinar, and we're very happy to be here to join. So yeah, my name is Israel Gross. I'm a co-founder of L7 Defense, and I'll be happy to present today, the API security challenge and talk about with you, present and answer any questions at the end.
Excellent. All right, so we can start. Actually, we'll start from the big picture. So API is the new norm in business agility and sort of key foundation for digital transformation, which was discussed many years, but now it's really the new reality. Practically, this is a modern paradigm of application efficiency that states automation at any time, anywhere, any device, any application. Maybe for those listeners that are not really familiar with the term. So API acronym stands for Application Programming Interface. It's basically an interface or communication protocol between client and server. And as mentioned previously, API drives efficiencies. And nowadays, when everything moves to software, we're witnessing a new API-driven economy that creates disruptions across all industries. And it's sort of, if I need to do analogies, so it's sort of a backbone of all the data and application set. I found an interesting example, sort of explanation of how it solves complexity. It's, the quote is from Jeff Lawson. Today he is the CEO at Twilio. And 12 years ago, he said, we have taken the entire messy and complex world of telephony and reduce it to 5 API calls. Well, this sentence probably says it all about disruption. And for people that are really familiar with the complexity of the world of telephony, 5 API calls, yeah, that's it. So in terms of critical aspects, modern applications rely on API layer as a junction that enables various forms of digital communications. In this diagram, you can see this digital application interaction with backend resources via networks. And clients can represent machine-to-machine API traffic, could be IoT, sensors, anything which is really machine-to-machine communication, user-to-application IP traffic, and developer access that's supposed to be internal and also external. With such an ocean of API traffic from those different sources in north-south and also east-west, assurance of API functional state is critical for business continuity, as volume, velocity, and variety of attacks really expanded lately, and just starting point. So as everything is really connected and dynamic, massive move to digital business has increased exposure to attacks, and IT security teams overwhelmed to handle so many changes. And now let's move from the big picture and drill down to API market and the challenges in detail. So Israel, go ahead.
Yes, so here I want to move forward and talk about what's API security. As Zev, you mentioned everything today's APIs, so of course we have to secure those APIs. And I use this terminology a lot, so when you ask people what is API security, you usually get 10 different answers from 10 different people. So we need to think about here today how to actually categorize the API security, talk about the aspects that need to be secured, and how should be the best efficient way to secure them. So next slide, we want to discuss about the API economy. So API economy, we see it growing now as the Akamai presents that 83% of all web traffic goes on APIs. And you can see here in this graph, the numbers of open API, published APIs outside, is increasing every year. So the numbers are continuing to grow dramatically every year. And this started from the digital transformation. It has the IoT devices all connected. And of course, now we see one of the strongest trends about the open banking regulation. Regulation drives also this market where the business goes through the APIs, and you'll have to give back the connections to the API management tools and others. The idea behind this is if you want to grow your business, you have to connect to more and more facilities, more and more interactions online. Thinking about just in the COVID-19 issues. So the COVID-19 just brought us to buy much more online, produce everything online, everything become an online platform connecting those APIs. So this market will also continue to see a big peak in this year and the next years afterwards. So we can see if you're talking about some numbers that organizations have average of 363 different APIs per organization. These APIs are published outside, and some of you don't have control what's actually exactly published. And when Gartner looks on this for the risk for the coming years, this year and next year, it looks at one of the major risks when it comes to those APIs. So they claim that 9 out of 10 attacks will come through those APIs, where the total damage of API risk from coming from those attacks will be about $600 billion. So we talk about where the challenging is to secure the new normal of traffic. The new normal of traffic is where either the hacker's going to come in because that's where the money. So next slide, we're going to present next slide more about the options of the APIs, how the API works exactly. So when we talk about the APIs, those communications go back and forth from the database, go to the end customer end user. They sit usually after the firewall, before those backend servers. And there you have two points to look at. One is about network operation, and then security operation. So these two come in the API, and they're both relevant because when you have a direct transaction coming from a mobile device directly to the data center through those APIs, so a lot of time you get direct access to the backend servers, and this means a lot of security parameters that don't open the traffic. They have no clue what's going on exactly and how to secure them, and this becomes the main risk. So this is the point we try to emphasize here is exactly the point between those database servers, the backend servers, and all the outside of the organization. So we have to secure this perimeter, the inside and outside of this of these data centers. Next slide. So I want to give here several examples. So some examples from last month. So you probably know the OkCupid, this very famous dating app. This last month was exposed that 50 million users' data through an API. You could have exposed the data, so you can see private data of people. You can change data, you can download data, and just because one of those APIs was open and helped, those hackers to actually get access to a profiles, whatever profiles they want. So this was one example. Another example is Meetup, also from the last month. Meetup is a very interesting use case where me personally, I have a group in Meetup, so I arrange events and conferences. Used to be frontally, but now it's more about online conferences. And then someone can access through this API that are published outside. You can access my account or any account and just like take control on the account, and do anything you want in that account. So this is another where someone did not close hermetically the API. And another use case is one of the more famous one is the Uber use case. We love to use this use case because this use case where the developer of Uber gave more access than needed. So for example, I can go on my Uber taxi and not only see what my driver is rating, what people wrote about him, but actually I can see also his finance. I can get access to more information. There was another problem with the Uber, for example. I could go on one taxi and also give rating for taxis I wasn't there because those APIs were not closed hermetically. So these are the examples. So these two left ones are from the last month. Uber was previously a year ago, but some of the examples to feeling how this API breaches can affect us all. Next slide. So traditionally, we used to secure these web applications, also those applications who communicate outside. We used to use security with a general web application firewall. And I want to explain today why this doesn't fit anymore to this generation of problem. Because APIs are very dynamic. They change all the time. You can have a new functionality, new parameter, a new argument. Arguments can change, parameters can change. Everything is always changing. So for example, we have a customer that has 3 updates a day. This means 3 updates a day, the security team will have to go and humanly go on the existing WAF and explain what is allowed for each of those changes, what's good, what's bad, do pen tests, and try to evaluate exactly the whole thresholds and schemes for everything. This is impossible when you have 3. So think about a customer that has 1,300 updates a month. No person, not enough team will be able to actually close this. So the idea is now everyone understand the world of security for APIs cannot come from the web application firewall. And these bullet points I'm presenting here are actually from this June, big research from June that came out that existing WAF are not suitable for today's risks. And that's why you see 50% of security managers claim that the API can be bypassed very fast. A third of the companies almost say that they're not able to actually configure the policies. And you can see also last line is about if you let this WAF work and don't teach it about the changes, you will get a high false positive as 30%. This is a very risky organization. They cannot have the WAF not updated. If it's not updated, they will block legitimate customers. Because for them, if the WAF has a rule, it's closed, but someone in the development team changed and give more visibility, more functionality, and the customer will want to log in, but he cannot do it because the WAF is blocking it. So this is the risk today, and this is where we see that the existing web application firewalls are not able to actually work on this type of problem.
Okay, so maybe, I thought about maybe stop here and do a quick webinar question for anyone that's on this active webinar. And the question is, who is responsible for the API security in your company? And you can click on it. We can, actually, I will launch the poll. So let's see what we have from the viewers. Interesting.
Yep. So we see different answers here. That's interesting. Yeah.
Okay.
Keep it.
So it's keeping up. Okay. Let's see what we're gonna get here. But absolutely, yeah. It's kind of fragmented answers we see here. Okay, we're gonna probably end the poll because we see, I think the result is interesting here. Maybe you wanna comment on this one, but you see where it's leaning right now based on the last few seconds. Okay. Okay, so I will end the poll for those that couldn't really click or. And yeah, we have here 30% mentioned that people that are responsible for the API security in the company's IT, 20% security operations, 30% DevOps, and 20% more than one answer. So you want to comment on this, Israel?
Yeah, so this is interesting because it's an emerging risk. So I can tell you now, some people look at it, and it makes very sense for me where people see this interaction. Who's in charge of this? Is this development team who working on the APIs all the time, or maybe it's the traditional IT security managers? This is what we see also today inside organizations. So it's something we can see. Yeah.
Okay, good. All right, let's go to next slide.
Yeah. So I would love to present here about the main risks for organizations. So we talked about in a high level about what's the problem. Let's talk specific examples. What should an organization be prepared when it's talking about API security? So the first thing is to get a visibility of the risk. What that doesn't exist today, as customers, they don't have the visibility. Which APIs, for example, are sharing private information? Which APIs have actually access to the database behind? There's a lot of those critical points. So as an organization, you want to be focused and you want to have a risk map of the APIs, not as which APIs you have. So which APIs are more risky for the organization? The first thing is you want to visual and understand what existing you have. And when you know which endpoints, for example, are sharing information, this is something you actually can validate. But the first thing is to know what you have, where you're sharing data, where the risk is. This is the first thing. Second point is about the type of attacks, the automated attacks. When we talk about automated attacks can come in months. And every day, change the parameter, change the API method, and come with a million different bots. And it would look actually as a normal user trying to log in, and tomorrow a different user logging in, and they all look normal. But actually, if you cannot identify, there is a sort of a command control behind it that has this script that's running and changing the parameter. If you cannot identify this, at the end, they will have this big database of username and password they bought or stole from other companies, and they can run it against a system. And then they will be able to see if people use the same email account and the same password, they can hack their accounts in someplace else. So this automated attack, so it's called OS Top 20, this is something you have to identify. This is one of the largest risks for those organizations where you have a username and password login, for example. Number 3 is about top 10 API security. I can tell you that this is the black hole today for organizations, because when a customer logs in with a multi-factor authentication, it gets SMS. We know this is the user. He gets a phone call, whatever. Another authentication is done, and it's for sure a user that's trying to log into the account. From here, the security team has no visibility. What is he actually trying to do? Because we know it's a good user. We know he has account. He has a bank account by us. We know it's him logging in because we did the two-factor authentication, but no one is actually validating if now, as I'm a user trying to log into to the admin of the system behind. So this is one of the major risks, authorization bypass. I'm trying to do things that we're not allowed to. I want to give another example. You get a token with to log in to see your invoice you get from telco or from electricity, and you click on the link. You go into that and you see your invoice. That's good. So we know who is a customer because we know from where he logged in. We have also this information. That's good. But think about us and were able to find if someone changed the number of the invoice, instead of 10 at the end, put 11. I can see someone else's invoice. Who knows to tell me that I cannot see someone else's invoice? So the authorization bypass is one of the critical points, because this is something has no clue for security. What is he actually trying to do behind the connection? This is one of the major risks. Another one is about fraud, and I want to tell why is this fraud becoming more and more relevant. Thinking about where you don't have the information who is the end user. For example, I'm logging in to a fintech company who gives loans, and they try to get the data from my bank. So the bank doesn't know exactly that I'm logging in, has no clue, has no information where I'm logging in, which device I am, where, all of this information they used to have because they knew who's the end customer. Now there's like a smoke screen because I'm logging in through a third party. And this third party doesn't have all the information or doesn't share all this information with the bank. This means there's a lot of barriers that were in the past were able to actually detect any attempts of fraud. Now it doesn't exist, and this is why you have to bring here new perspective of fraud. Understanding, is this a normal pattern of requests? Is this system is trying to ask for me from several requests? Is this normal? And such and such. So this is the fraud issue becomes another critical point. Next one is about those classic top 10 app security attacks. Could be SQL injection, LFI, XSS, all of those classic attacks. When you're talking about an API level where it changes all the time, you have to bring security that will be actually adjustable to all those changes and give you a security per API itself automatically, of course. And the last one is about understanding the content that can cause a DDoS attack. So DDoS attack can come from sending a lot of requests or sending a very small number of requests, but with very heavy payloads. And this can cause the same impact as a very heavy attack. But this is something doesn't get any clue from today's system because they don't look at the content. They look about how much request, what's the volume of traffic. They don't look at actually the content. So I would try to summarize. These are the top 6 risks organizations facing today. With all the APIs, information back and forth. And this is something we would love to face today in the next slides.
Okay, so as we've seen in previous slides, there are various challenges presented on application securities that really extended the attack surface through those distributed services and data over different types of networks. And multi-dimensional network security and applicative security requires attention. Specifically, the impact is really radical given the fact that API can be shared by hundreds of applications. So attacks performed through API will trigger a lot of operational teams' nightmare. Again, it will be reflected on NetOps and SecOps. And security breach in such targeted attack can be harmful to hundreds of applications. And when we look at 3 major radiuses of risk, we can map it to exposing the sensitive data, interception in communication flows between backend and any type of device, which could be mobile, smartwatch, smart car, robot, bot, microservice, you name it, any client of your application. And the third radius is denial of service performed against backend resources. So API security framework as a counterpart stages will be, and you could see those 4 stages here. So stage number 1 is really identify the API traffic and steer it or intercept it to security operation lane. The objective is to perform traffic profiling, which is very important. I would like to inject the right traffic and the adequate capacity of traffic. There is enormous capacity of flow, so we have various anchors of inspection, that we can do. We really want to focus on this. Stage 2, since the vast majority of application traffic is encrypted, the decryption stage is critical. To ensure encrypted API traffic is analyzed by security operation tools. But one thing we need to bear in mind is privacy regulations such as PCI for transactions, again, bank transactions, or HIPAA for healthcare regulated data, or GDPR are mandated today. So sensitive private data should not be exposed. And we have option to perform masking, and sensitive payload before delivery and keep the sensitive data in motion safe and private. So that's additional thing which is important to mention here. Stage number 3 is the API traffic inspected for abnormal behavior. Attack detection, mitigation, this is a critical stage that includes various processes across security stack. Stage number 4 is the data loss prevention that perform proactive actions to stop exfiltration of data. So execution involves various processes, including even REST API via threat intelligence stack, so that we can block, filter specific communication channels. Okay, after reviewing the API security resolution framework, let's have a glance on deployment use cases. So in terms of, there are two use cases. In terms of visibility into API traffic, there is an inline and out of band. Inline typically categorized as reverse proxy. In this mode, inspection requires placing this the immune tool inline on the network for real time. And API threat analysis done really in real time across the wire. The out-of-band traffic analyzed and intercepted, copied to API security inspection according to resource identification criteria, and API threat analysis done in out-of-band from production network. So let's jump into our joint solution snapshot. So this solution is really to deliver this agile IP security. Our joint solution provides this operational efficiency in API threat detection and close the API security gaps as discussed in previous slides. Layer 7 defense API security solution integrated in Niagara's open visibility platform. So our joint solution serves as a shared platform for network operation and security operation teams and positioned strategic core of the network. So with that said, practically you get agility of new applications, easily update or upgrade, simplicity of managing tool sprawl, and offload, the hardware traffic offload that can accelerate traffic in various forms. And practically, we see here those three main stages: the network profiling and API traffic discovery, visibility into decrypted layer 7 application payload, and API-related traffic insight with the API security discover, detect, and defend options. So what do we see here? It's actually this slide represents the Agile Architecture. The idea is that Niagara Open Visibility Platform provides open and high performance deployment hub. It can host virtualized solution combined with intelligent traffic delivery capabilities, which could be, again, those virtualized solution could be security and networking solution. And as discussed previously, as each API in a critical part of multiple application, precision in attack detection and mitigation becomes a must. So highly integrated API security inside packet broker architecture enables this agile solution. And when we look at this high performance architecture, we really meet core networking reliability, scalability, and performances required typically by the networking teams that serve security operation team. So we have those terabit capacity scale that we can intercept traffic in any speed. We can perform packet brokering in terms of the traffic profiling and analysis, a high availability of bypass to manage and ensure failover in transport to the network. The encrypted traffic decryption, SSL TLS engine that enables this visibility of traffic to immune, the layer 7 immune solution, plus, as I mentioned previously, plus extended visibility and packet manipulation such as masking and other advantages and advanced traffic intelligence rules that we can do. Practically, in terms of scale up and scale down, so we can perform load balancing traffic from multiple links to immune solution to layer 7 API tool, and we can scale on demand based on capacity requirements. So we can spin those engine machines on top of our platforms, and this is a big value when we look at the previous discussion on capacity scales, the different type of attacks, and how we can cope with them. Israel, you want to move to demo?
Yeah.
Okay, so just let me know when. Yeah.
Yeah. So before we start, so maybe one word. So giving you a dashboard, so what you see on top of the Niagara Network packet drone. So you can see also on the difference. This is a dashboard where we analyze the traffic. In the right hand side, you would see the IPs. In the bottom, you see the notification alerts. And in the center, you can see actually the real traffic coming in. What's normal is green, what's not normal, we see different colors. So if you can play now the video.
All right.
So I put a short video, just not to take too much of the time. How the traffic normal looks in, and then we see an attack starts. We see a peak in the traffic. We start to analyze exactly which IPs are coming in, create dedicated signatures to block it. You can see already the risk, the current system risk goes up to 100. And now already now after a few seconds already the system already start mitigated. And now you can see the differentiator between the green is the good traffic and the orange, yellow is the bad traffic already mitigated. So this won't have any interference to the system. The system learns in real time and actually can block them and identifies them and just take them out. From here, what you can do, you get this you get the full report, which attack happened, which IPs came. A lot of information we give out of this box because we believe in sharing the data. This data belongs to the customers. They want to see this data, it's theirs. So you can take here all the investigation. You can take it here after to do forensics. You can actually manage those and start writing better rules, better signature or better development for the team, taking this back to the reports with developers. Listen, you left here a hole. Please close it, please manage it. This is the idea. So we get a very short video, demonstrating one type of attack where they have a lot of both behaviors and some DDoS signs. This was one type of attack, and be happy, to share a full demo with whoever wants afterwards. If you want me to share a full demo, you can leave your email contact here in the chat, and we'll schedule a full demo for that.
Next right, slide. So should we jump to, let me see, yeah, we can jump to a case study, in fact, our joint case study.
Okay, so I want to talk about today a case study we have together. So L7 Defense installed in a large national bank. And we came together with Niagara Networks. Niagara Networks brought the physical server, Packetron, L7 Defense above it. So Niagara Networks decrypts the traffic. We see open the traffic, and then we can actually create the signatures. This use case is specifically for a very complex DDoS attacks that the bank wasn't able with several tools to actually identify what's normal, what's scrappers, what's bots. They were not able with several tools they had there, and they called us inside, and that's what we brought the solution, where actually gives them clearly visibility and identify the possibility. From here, they can take, okay, this IP is now is used by a command control as a bot. We can quarantine him for hour, day, and you can just take decisions by this how many times he's trying to hit the system. And this is how you minimize the effect on legitimate customers, because you have the possibility to manage all of this risk coming from those many bots. So it comes from the complex here, because it comes from many different IPs and different parameters. So this current system, we're not able to actually identify what's good, what's bad. With L7 Defense together with Niagara Networks, this is working. This is a good solution from bank. And it works. It gives them the full coast-to-coast solution to protect these use cases.
Right. So basically, this is just was a representation slide of what you already discussed. But as you previously pointed out, most of the bullet points, I believe that one maybe thing that we need to mention here, that one of the things that was mentioned by the team there was that the rapid integration within the security operation and network operation frameworks was really fast. And I think that this is also something that was a big plus for this joint solution by two companies, the best of breed, which enabled this fantastic case study. Anything that you would like to add on this, Israel?
I think it's a good use case where we find users who want a solution on one box, give them the whole package. This is something we see from a lot of big organizations. They don't want to deal with several vendors. They want one vendor to give them the whole big, from a metal to the software above, and gives us as one package. It's a big advantage for both of us, L7 Defense and Niagara Network, on this joint collaboration where we can give a complete, a holistic solution to this problem.
All right, so we're getting to the summary. I think in summary, Niagara Networks and Layer 7 Defense joint solution really delivered this best-in-class agile applicative API security. I think we try to give you the essence in this webinar, and we'll be glad to communicate more. I would like to emphasize that this collaboration is part of Niagara's strategic open visibility technology alliance that onboards a wide spectrum of security and networking applications from various vendors. For those that would like to review it, you are more than welcome to visit our website. And as part of our Silicon Valley ecosystem, we provide solutions that empower the open and agile paradigm and quite interesting ecosystem to various companies, including the ones that maybe you're familiar with. So Israel, you wanna make your kind of summary here?
Yeah, so my summary is, we are very happy to be partners with Niagara Networks. We're very happy to be here in this webinar today with you, and thanks to all the people who joined. Yeah, and I believe this should be, the next generation of platforms who aggregate the best solutions on it and give it as a one big a platform for security. This is what I believe in. We're really happy to be part of this partnership. And this is for my, working with you and looking to work globally more and more with Niagara Networks.
Right, excellent. So, to wrap up, really what you gained from this webinar, what was the 3 points that we can take out of this webinar? So one, I think all in one, save time and money in terms of this deployment, and simplicity was very important in terms, hopefully again, out of jumping on the key high-level activities that I would like to summarize. Operational efficiency, which is very important nowadays, because again, you could see collaboration of network operations and security operations always required in order to cope with unprecedented world of digital that is just getting more complicated. And reduce risk, really, on the API layer. I think detection, definition, and defense on new applicative posture threats. This is what really was highlighted by Israel and Layer 7 defense solution. So with that said, I think that now we really would like to go to this free of charge, get free this, submit your name, your business email now, get free of charge penetration test for applicative threats. This bonus giveaway is granted only for people that attended our live webinar, so get this value now. Israel is here really, so if you're already posting your questions, I'm not sure if again, if we got specific questions. I'm trying to see Israel.
Yeah, I see a question from David. Can this solution replace existing WAF? Yeah, so actually the answer is yes. So together, L7 Defense together with Niagara Networks can replace a completely WAF as giving a DDoS bot and a WAF solution and the API level. So yeah, so this is actually a whole solution for instead of existing WAF. You can put this in organization, so you get this load balancing and all of this as a set of loading in one place. Yeah, so that's the answer to your question.
All right, so if we don't have any other questions, thank you, Israel, for joining us and introducing the Layer 7 different solution together jointly. Thank you for the audience, and we can close this webinar. Thank you.
Thank you very much.
All right.